In this video, we're going to talk about some characteristics of a function. So we'll identify what a function looks like when we're given ordered pairs, a mapping diagram, a graph, and an equation, and then also talk about what function notation looks like so that we can evaluate equations. So a function is like a specific type of relation. So here it says that it is a correspondence or relation from a first set domain to the second set range. And that is pretty similar to what we define as a relation, but a function specifically has to have each element in the domain corresponding to exactly one element in the range. So there aren't two elements in the domain that can there can't be an element in the domain, our x values, that go to two or more different y values. So if we look at these two examples, we've got two relations here with a set of ordered pairs. This first one has 6, 1 and 6, 2. So we've got x equals 6 corresponds to y equals 1 and corresponds to y equals 2. Well, that's telling us that one element from our domain is corresponding to multiple elements in our range. That doesn't fit our description of a function. So while this is still a relation, it is not a function. But here we see that if x equals 1, that goes to 6, and x equals 2 also goes to 6. And that's okay because they are separate elements in the domain. So basically, we're making sure that we don't have our x values or any elements in our domain repeat with a different element from our range. So if we look back at the example from the previous video where we've got these 5 teams and their number of wins, our ordered pairs in our relation were right here. So we've got a couple teams that have 86 wins, Chicago with 79, and then 2 teams with 65 wins. Well, if we put that together as a mapping diagram, we see that we already defined our domain to be the teams and the range to be the number of wins they had. Now, because this is in order, the arrows are kind of all over the place. I could rearrange this so that the arrows look a little neater and it's easier to read. But you see, each element in the domain goes to only one element in the range. None of these teams have 2 different win totals. Whereas over here, we could say that 65 wins corresponds to both Cleveland and Kansas City. And if we define this as the domain, then that would not be considered a function. So this mapping diagram is correct in describing a function with our domain here and our range here. Looking at graphs, again, we want to make sure our x values don't repeat, but it's a little different way of looking at it because it's visual. So if our x values don't repeat, then there's not going to be 2 points that are vertical from each other, where one's above, one's below. And so if we take a look at graph B, let's say that x equals 1 is right here. Let's make a line. Oh, that's not what I wanted. Do a straight line since I can't quite do one freehand. So if we take this line here, and let's say we bring it to x equals 1. Let's say that's right here. Well, there are 3 points here on our graph where x equals 1. So we could have a y value of maybe that's 4, 1, and -5. So that specific element in our domain corresponds to more than one element in our range. And so because we notice that, with this vertical line, we can do what's called the vertical line test. So you can just take a line or your pencil and drag it across the graph, and if at any point it touches the graph more than once, then it is not a function. So B is clearly not a function. Part A, there's some parts that look like they are vertical, but we don't want to assume that. So even though it looks here like it might be vertical, we can just assume that it is only touching the graph at one spot at all times. So A is a function. We said B is not. C is a function. And then D, any circle that you see, it's always going to touch at more than one, in more than one place for the majority of the graph. So our last example here for defining a function is with equations. Again, we only want one x or one y value for each x value. Yep, I wrote that wrong. So one y value for each x value. We don't want multiple y values for x, because then x repeats in a sense. So if we were to put this into y equals, we get y equals negative x squared plus 4. So that's just a parabola. And if we look at a parabola, that's, well, since this would be flipped, it'll be a U shape or upside down U shape. And we do our vertical line test, and that one passes. But if we look at y squared equals negative x plus 4, well, now this is like a square root value, or the quadratic function tipped on its side. So in this one, we're going to have, let's draw it out here. This one we're going to have this general shape. Okay, so that one's going to be okay. But then this one here, since we have y squared, it's going to be something like this, that general idea. And if we take a vertical line test, then it's going to cross at multiple spots. If we think about, let's say when we move x over here, whatever that value is on the right, let's say we give x a value so that the right side is 16. So if we have y squared equals 16, well, y could be 4 or negative 4. Okay, so there's two y values that would correspond to a specific x value. 4 squared is 16 and negative 4 squared is 16. And that's how we get an example like this where the vertical line test doesn't pass, because we are going to cross it at two spots throughout the majority of our graph. So the difference there is here the y value has an exponent that is odd, and here the exponent is even. So then if we look ahead at this one, which looks kind of messy, that y value is odd again. So if you were to type this into a graphing calculator or Desmos, you would notice that once it goes back to an odd exponent for y, it becomes a function again. So that's kind of the thing we're looking for in equations. Just at quick glance, is the y value have an odd or even exponent? If it's even, it is not a function. So this would be a function, this would be a function, this would not be a function. And the last thing here, function notation. Instead of y in our equations, we're going to use f of x, or some letter that represents our function. So we've got x as our input, and then our y, or f of x, is our output. So we're going to input x into whatever our function is, or whatever our equation is, and it's going to give us some output, which is our y value. So if we think about a graph, we'll take an x value, plug it into our function or equation, and it's going to give us some y value that it corresponds to. And we read this as f of x is equal to, and then the rest of the equation. Notice that this is not f times x. I know it sort of looks like that the way we write out equations in math. This is a function of x, and so another way of saying this, these two parts that are equal, we say that y is a function of x.